Day 16,
Day
Car Audio School.
16 of Car Audio School. This is your school that will teach you how to do it yourself, become a technician, become a shop manager, or become an owner of a shop. This is my body of work, my online resume to teach you how to stay out the shops. And all of this is for entertainment and educational purposes only. So today we are going to talk about impedance or ohms, and we got a lot to talk about. This is very easily a 1 hour discussion. We're going to try to break this down into about 10 or 15 minutes. If you do want the full discussion, go to Nimbus Electronics and Sound on YouTube, or I am Sleepy Digital on YouTube. So let's get into it. As we discussed maybe 10 days ago, with Ohm's law, resistance is measured in ohms and symbolized by the omega symbol. It's the fundamental opposition to flow of electrical current. It's an inherent property of an electrical circuit, and you can think of it as friction or electrical roadblock that impedance, the movement of electrons, which is what current is. Current is electrical water flowing through a wire or conduit, or whatever you want to call it. Voltage, on the other hand, is the electrical pressure that pushes the current. So we have something pushing that water, either from a water pump, we'll call it the battery, which is a storage, pushing the water, the current, through electrical conduit. Now, without voltage, there can be no current flow. It's just sitting stagnant water. The relationship between voltage, symbolized by capital E, the letter E, and then current, symbolized by capital I, and resistance, capital R, defined as Ohm's law. So we talked about this way back in the beginning, and it's coming full circle to understand this new concept called impedance, better known as resistance. So this is also defined by Ohm's law. E equals I times R. So we'll come over here and we'll talk about this for just a quick second, and think of impedance measured in ohms as the resistance your audio signal faces as it travels through a wire or component. It's like how hard it is for electrical water, the audio signal, to flow through the pipe, the wired or device. So we're talking about it physically flowing through the wires connecting the devices or components, or at the actual device, like the amp, flowing through the amp to get back out to where it needs to get to. And then a quick breakdown of that: resistance for AC, alternating current. Remember how AC goes back and forth. Impedance is like a more complex type of resistance that takes into account this back and forth movement. So even the back and forth movement of your hands, the resistance of you doing this builds up heat. We're taking into account that dynamic of the audio signal or the alternating current moving back and forth. And then it's not just about the thickness of the wires. So while a thin wire, and we've talked about this, while a thin wire has more simple resistance, like pushing 1,000 gallons through a straw. Impedance also depends on other things like how the signal frequency changes. So remember we talked about the dynamics of the audio signal and how, I said don't laugh, how it fluctuates literally like this through all the wires. That has to be taken into account also. And then matching is key. In audio, it is important to match the impedance of different components like headphones and an amplifier. If they don't match well, you can lose sound quality or volume. And this happens all the time. People will grab any kind of speaker and put it with any kind of amplifier and expect for the amplifier and the speakers to perform to spec, and they're not compatible. I'll say it that way. They're not compatible. So we'll come back over here because 6 minutes in, trying to get to the meat of this. Okay, so with all that being said, understanding speaker impedance is vital for several reasons in a car, audio system, or home system. Same thing, just a smaller room. Amplifier compatibility. Amplifiers are designed to work optimally with speakers within a specific impedance range. Connecting a speaker with a significantly lower impedance than what the amplifier is designed for can cause the amplifier to draw excessive current. So it needs a lot of water. It needs a lot of electrical water, leading to overheating the resistance. You're pushing a lot of power through a tiny straw, or a lot of water through a tiny straw, when you need a water hose. Where am I at? I can start over. Connecting a speaker with a significantly lower impedance than what the amplifier is designed for can cause the amplifier to draw excessive current, leading to overheating, distortion, and potentially damaging the amplifier. As much higher impedance speakers might not draw enough current, resulting in, so this part is talking about if you get a speaker with a higher impedance, more than the amplifier can handle, it could actually result in lowering the power output from the amplifier. So basically you have a water hose and you have a little trickle flowing through. The pressure to pipe ratio is not correct. So there's not enough power, there's not enough current, there's not enough voltage to power this speaker because the conduit, the hose, is way too big for that little trickle flowing through. So power transfer. The impedance of the speaker directly affects how much power an amplifier can deliver to it. Generally, for a given voltage output from an amplifier, the lower impedance speaker will draw more current and thus receive more power. So P, capital P, equals E², I know, just roll with it, divided by R, or P, equals I², I know, just roll with it, R, delivered from Ohm's law. So this is why amplifiers often specify different power out ratings for different impedances. And then we'll give you an example. So 100 watts at 4 ohms, 50 watts at 8 ohms, and you'll see this on the back of amplifiers or home receivers that you hook up speakers to. It will tell you what speakers you should be hooking up to it. 10 minutes. So speaker performance. The impedance curve of the speaker can provide insights into electrical behavior across the audio spectrum. Significant variance of impedance can affect the frequency response of the speaker and how the amplifier interacts with it. For instance, the impedance peak at the resonant frequency can influence the bass response. So I don't have a clearer way to explain that. Let's just say that your mids and your highs will come through clear, but there may or may not be any bottom or bass to it, based on the speaker performance and how you have it hooked up to a receiver or a amplifier. We'll say it that way. And then line output converters, or LOC. When integrating aftermarket amplifiers with factory head units, and we'll talk about this later, I'll teach you how to install these things to get the sound to the amplifier so it can correctly, I'll say, know what to do with it. I'll say it that way. Devices called line output converters are often used. These devices sometimes have power ratings and must handle signal voltage levels regardless of the factory unit's output impedance versus the aftermarket's device input impedance. Ohm's law can be used to understand how these power ratings break down in terms of signal voltage at a given load of impedance. So we're 12 minutes in, we're going to wrap this up. In summary, impedance is the comprehensive opposition to alternating current, AC, encompassing both resistance and reactance, particularly in inductive reactance of a speaker's voice coil. So how is it going to respond? Because that is AC signal going to the speaker to make it, I forget the technical term for it, but for it to press out and retract back in to give the sound or the signal. While speakers are given a normal impedance rating, their actual impedance varies with the frequency of the audio signal. Understanding this concept is crucial for properly matching speakers and amplifiers to ensure optimal performance and prevent damage to your audio system. So, definitely impedance you want to keep in mind. Definitely RMS you want to keep in mind. Definitely peak voltage, or maximum. Sometimes it'll say 1,000 watts, which is not continuous. It's for a very short burst period of time, whereas RMS is continuously without any issues. You want to be able to match all of those up to have a proper audio system within your car, on top of knowing what your alternator is putting out to keep it all running. Also, knowing what kind of battery you have, which is your pool for electrical water for the whole vehicle to use. So that's it for today. Definitely, if you want a longer explanation, and with visuals and all that, go to my YouTube, Nimbus Electronics and Sound, or you can go to my other YouTube, I Am Sleepy Digital, and get the longer explanation, because it gets deep. It's too long, and I'm already at 15 minutes. So thank you. Come again, donate, tip your techs, take care of your people, and your car won't catch on fire.